Thank you. Thank you. And I would like to thank all of you for participating to this final event. As a coordinator, I need to thank you. I want to thank the partners of the project and also the national experts collaborating with the AFG, the invited speakers and all the attendants today. The panel of experts, the joint panel of experts who helped a lot us during the project, and also the European Commission officers that support us in a different way during the project and allow us to arrive at the end of this project. Before starting with the real presentation, I want to tell you what I learned from KINDRA in the last years. I'm an academic researcher working since 30 years in groundwater field from the academic point of view. But in the last 5-6 years, I was involved in many organizations and activities with the European Federation of Geologists, with the working group groundwater, and with the International Association of Hydrogeologists. And I discovered also other things that research in groundwater topic. Of course, I knew since the beginning that groundwater resource must be balanced between human and environmental needs. But during these last years, what I learned is that groundwater is a really society-related topic. Really society-related topic. And from this point of view, communication, education, dissemination are very important to help groundwater to be understood by the people, because it's a hidden resource, as I mentioned before. Now the project is going to the end, but our work on groundwater issues will continue with the help of the KINDRA outcome, I hope. And I'm supposed to be involved in KINDRA and in this activity also after the end of the project for the next year. And I'm very happy for this. And just to involve you in this type of approach, I want to remark the title of this final conference, which is Making Groundwater Visible, Accessible, and Treasured. As I mentioned, groundwater is a key topic on modern society, and of course groundwater is the hidden part which is difficult to assess, evaluate, and communicate. So our main scope was this one, so to reveal KINDRA to the groundwater, and by achieve a better understanding of the groundwater topic, providing an overall view of the scientific knowledge existing across Europe. So the first word is visible, and we afford this challenge by dissemination activity all along the project, but also raising the role of groundwater on technical and decision-maker table inside the water community. We participated in several activities in the wider water community in the last years. Second word is accessible, and this is the core of the project. We realize a new classification system intersecting the theme of the groundwater issues like operational actions in a multidisciplinary approach by individuating research topics with reference to societal challenges. The second part of the accessible approach is the collection of the system information on groundwater research knowledge in a public access metadata searchable tools, the EIGR, that will be explained later. And at the end, with this conference, in the last 6 months, in the last part of the project, we also moved to the treasure world. How? By analyzing gaps and trends in groundwater research knowledge to define a recommendation aimed at safeguarding groundwater resources in Europe. So we want to put groundwater higher in the agenda of the European Commission, and we want to try to support to solve the problem that groundwater issues are rising in society and in policy. This is the scheme of the project. So the main aim of the project was to create this inventory on groundwater knowledge. and use this inventory to identify critical research challenges in line with the implementation of the Water Framework Directive. You know that we had also the support of the joint panel of experts. We help us not only in the classification, but also all along the project. For the inventory, we involved 20 third parties, so the national representatives of the EFG network. Some of them are now in this room. And finally, this dissemination activity has been another important pillar of the project, thanks to the dissemination capacity of EFG, and of course our dissemination partner, La Palma Research Center, and also by collaboration with other groups, organizations, and organisms that are dealing with the water topic among Europe. The flow chart of the project is on the right, so we move from the new classification system, creating an inventory, field inventory, and testing the population of the inventory. And now we are in the final steps, which are related to research gaps and corresponding suggestions for research agenda, and of course to allow that our inventory will be available in the future also for as a public access permanent searchable service for all the groundwater community. But it's really needed a classification system about groundwater. This was one of the first questions we had at the beginning of the project, and we realized a survey, a user survey in 2015 involving several people from research, from environmental NGO, from association representing industry and agriculture, interesting group, consultancy, public bodies, and so on. And we received a positive answer on this topic. Just to summarize some of the results, we need a new classification system for groundwater. As you can see, 88% of the people reply, yes, we need it. And also we asked what kind of keywords in the research information are used in your activity. You know that several of these are being included as a main keyword in our classification system, like mapping, monitoring, modeling, groundwater level, and so and so. And another important result is about how to access this information, how you search information on your topic, through a catalog, by geographical names, by maps, or keywords and others. So, taking into account this framework, we try to build a new classification system evidencing the main keyword, evidencing the giving the possibility to use a catalog with search option by maps, keywords, and so on, so to make a comprehensive approach able to give information in the more easy way we can. And at the beginning of the project, we use also this slide to locate our KINDRA project inside the big field of water. This is an example of different water issue that can be investigated by research, but also by policy, but also by societal challenges. And you can see that KINDRA at the beginning was limited to of course, the directive and the field of groundwater. It's something about the water resource monitoring. This is not really our intention, but at the beginning, this is the situation at the beginning of the project. During the project, we are convinced that we enlarge the field of the KINDRA activities. Oh, sorry. Doesn't work, the animation, of course. The animation starts to enlarge the KINDRA field just to arrive to include the flood and drought management and surface water, climate contribution to water policy, ecosystem services, water cycle, and ICT on water too. Unfortunately, it doesn't work. So during the project, our approach was to enlarge the KINDRA approach to investigate also other fields of the water issues not only related to groundwater, but in general to this big field. What about the classification system? As you know, the classification system has been based on a 3D approach, and the approach was to identify the societal challenges on the vertical axis to be compared with operational actions, which included the typical activity of the groundwater people, hydrogeological people, and the research topics, which identify the interdisciplinary approach. So the EGR cube, so the final results of the classification system is a cube that, by intersecting the three main axes, can compare and classify all the knowledge of the groundwater inside research topic, operational action, and societal challenges too. At the beginning of the project, we also investigated the possibility to approach by the semantic classification, but the idea on the basis of the classification is to compare the technical activities by an interdisciplinary approach with the societal challenges, taking into account that the water topic has a great importance, of course, in European society. This is the result of our investigated of the filling of the inventory. This is a 3D approach that you can see. We have 125 locations inside the cube, of course, because each axis has 5 main keywords. And as you can see, the composition of the record inserted in the EIGR, in the inventory, are very different. And the intersection reveal different amount of resource uploaded until now. At the end of the project, we can count on more than 2,000 records published and inserted into the database. And this filling has been done with the help of the 20 third parties. So each association at the national scale, involved at the national scale, relies an insertion of several input, several records, taking into account, of course, their own experience on the field of groundwater. So it's a subjective feeling of the inventory, and different countries include different information and different amount of records. Of course, at least 50 records. Some country went up 100 records or 200 records, and this is a distribution of the number of records uploaded by all the countries involved, all the national association involved in the project. But the content of the EIGR is not only about research, but it's also about knowledge. So we identified not only the papers, scientific papers included to be included in the database, but we recommend to the national expert to include what has been done at the national scale, which is not available by larger database at international scale. So like reports, results of the project, applied research project, also ongoing projects, surveys including relevant data and maps, consulting reports for ministries and other authorities, peer review papers, of course, technical reports and guidances, books chapter, and also databases. Of course, inside the inventory, there is only the metadata related to this information, and you can go into the metadata information for finding the initial information by link. As you can see, at the end of the project, we have the majority of the insertion are related to reports, and second with papers, but also books, maps, databases, technical reports, and other kind of document has been uploaded into the system. And this difference between research and knowledge is more clear by the classification, by the identification of the classes of the information uploaded in the inventory. we identify 4 classes. The first 2, class 1 and class 2, are peer-reviewed paper or conference proceeding, which are connected with research activity by academic. But we also included knowledge classes 3 and 4, which are related to reports from research projects, national technical journals, and so on, but also degree literature, which is not included in the larger database at the international scale. As you can see, the composition of the more than 2,000 records is clearly unbalanced, favoring the classes 3 and 4, which was exactly what we asked to the experts. So to emphasize the role of class 3 and 4, as you can see, 2/3 of the records are related to this knowledge, so non-scientific or not validated, completely validated data, and only 1/3 of the records are related to peer-reviewed paper or validated data and records. And this is another very important result of the project. If you go into the detail, a little bit in detail, in content of the IGR, the occurrence by 2D diagrams, or by slicing the cube, you can see some unbalancing and biased situation. If you go on the research topic and you investigate how the records are divided between the 2 societal challenges and operational action, you can see that societal challenge, climate, environmental resources has a very high number of records, which of course can be considered a bias, but at the same time can be considered as the underlining the very large importance of groundwater in this field. If you go, for example, take into account the general framework of the societal challenges and go to check what's happened on the 2 axes related to the operational action and to the research topics, you can see that geology, of course, is a big field with respect to the others, which is a real bias because, of course, we ask to geologists to compile it, to insert information into the inventory. And you can see that biology or chemistry or geography are for sure less represented inside the GR. In the future, or comparing this database with other databases, we can also identify, and we are identifying, that this bias is mainly related to the fact that the geologists are involved in including information. So another result of the project is that, of course, groundwater is an issue larger than hydrogeology. And we have to reinforce the interdisciplinarity of the groundwater field, not only taking into account the geologists, but also the other representatives like ecological scientists and so on. Just a look to the indicators we included into the database. The TRL is the technology readiness level, you know very well, is an indicator established by the European Commission, and it's included 9 classes. And you can see that many of the records are, of course, concentrated on the lower classes of TRL, and only a few, 12%, are included in the higher group, which include the TRL from 5 to 9, which is demonstrating that groundwater issue is a research topic and not only an innovative and market-oriented topic to arrive to the higher level of TRL. At the same time, we launched a new indicator, which is PRL, so policy readiness level, because we want to understand if the results of the information related to groundwater can be really transferred to the policy level. And we have 4 levels in this case. Peer, of course, with increasing readiness level from the PRL1 to PRL4. And also in this case, you can see that the majority of the records are related to the lower classes, related to the policy readiness level, and only 60% are related to the higher classes, which suppose a possible immediate transfer to the policy maker and to the policy activities. Okay. Another final information is about the number of the records in the IGR. Due to this limited number of data, they can be useful for investigating and for investigating gaps and trends. This is an example of a map can be realized with a WOS viewer tool, and my colleague will go in detail in a few minutes. This is the results of the records included in the EIGR. As you can see, there is a map with a density map which highlight some keywords like aquifer, drinking water, and groundwater resource. But this is this approach can be structured by hydrogeological topic. I try to understand if this approach can be represented by different topics inside the groundwater issues. As you can see, we can identify some subfields like groundwater quality, groundwater budget, groundwater environment, groundwater use, groundwater properties, which reveal that this approach is able to really classify groundwater research in a structured way, and we can extract also information from this database also with a limited number of 2,000 records. Finally, the challenge for the project. We have some bias, of course, in inventory, need to be solved by the interdisciplinary approach. The number of records can be considered sufficient, allowing the analysis of gap and trends, but has to be compared with larger databases, as you can see in a few minutes. We are looking for editors, so the inventory has to be continuously filled with new records, but at the moment the attraction capacity is limited. How to manage the inventory after the end of the project? We are asking for your help. We want to identify possible collaboration with other projects, international associations or entities we will see in the afternoon. And it can be linked or merged with other international databases on groundwater. We think yes, but of course there are some technical issues to be faced and analyzed. About the record upload in the EIGR, there would be a double control or quality control. One is the formal insertion control, and another one is the quality assurance control of the records. At the moment we manage, but we have to dedicate resources for this activity probably in the future. And there is a lot of other questions like classification system can be adopted by groundwater community after the end of the project, and is reflecting the research and knowledge in hydrogeology European scale. And the final user on national scale would have advantage in adopting this approach. There are some final questions to be answered as soon as possible. And at the end, I want only to remark that we need your help today and also in the future. All the users and all the organizations involved in groundwater field are requested to help us to overcome the end of the project. You know, the European Commission said the project is finished, you have to deliver your results, and there is no, of course, additional resources for improving the results of the project after the end. But we are convinced that we can overcome this takeoff with the help of all of you and other organizations and people can help us to take the KINDRA outcome alive also after the end of the project. Thank you very much.